in this lesson we'll be talking about control statements, that is to say the if and the for and the do. Probably the most important, the if and the for, are probably the most important statements in the whole of programming. So let's start off by taking a look. I'm going to copy this code here, and then I'll just move this onto another screen, and then I want to paste that code in there and just take a look at it. We've set the value of x equal 2. Well, x is equal to. Is x greater than 1? Yes, of course it is greater than 1. So that therefore we might expect that this line is executed. Let's find out. So if we build this, and then we can run the program, and then we do get the solution that yes is printed onto the screen. Now, we could have this on the same line, so that that will do exactly the same thing. If we're confident, we can just start a program without building it, and so if I just I'm confident that will work without going through the two stages, and of course yes is printed out once again. We could say whether it's equal to 2, well, just before we do that, we'll say x is 1. What will happen when we run that program? Well, absolutely nothing, because x is not greater than 1. 1 is not greater than 1. If we want to compare to see whether it is equal to 1, then we could use the double equal. Now, that means when you're comparing something, you use two equal signs. It's a common mistake not to put both of them in. In here, you are what we call assigning the value of x is equal to 1. So if I run that, then you see that you do get the output yes, because indeed x is equal to 1. But get the difference between the assignment and the comparison. If we want to execute more, well, we bring this down, that doesn't make any difference at all. If we want to put another line to be executed in there, then for example we could have another line like this, and then will both of those be executed when x is 1? No. What we need to do is to put it in some braces like this, and then bring that down. I'll just copy that out there, and then when we run the program, you should find that both of those lines are executed. Now, if we now try and use an else statement, so that if we put in an else here, then we want another line to be executed in the else situation. Well, I'll just bring this, copy this line of code, a control drag. Try and use control drag as much as possible. I'll just tab that across, and then in here I can say the alternative is no. Now let's see what happens in this case. Well, if I were to run it, it would run just as before, and it would print those two lines out. By the way, these two are called braces, and these two things here are called brackets, and these things down here are called parentheses. But we usually call these, in a lazy manner, we usually call these brackets as well, but really they ought to be called parentheses. Anyway, what's going to happen in this situation? Then these two lines, I assure you, will be executed. But let's see what, if I say if x is equal to 2, well, it's certainly not equal to 2, is it? So it means that it's going to look at this here and say, is x equal to 2? No, it's not. So it will therefore go off and do the else situation. Let me just confirm that that's the case. I could build it, and then I could run it, and you see you've got the alternative no being produced. Well, let's see how that operates. What I'll do, I'll put a breakpoint here, and now if I run the code, it's going to run to here, and that's rather nice. It's going to tell me that x is equal to 1 when I hold my mouse on it, and if I press the F11 key, it will go on to, you see that it jumped right across to the else statement, and now it's going to print no. But be careful when you get to this line. If you should press the F10 and not the F11, and it's what we call stepping over. I'll show you where that is in the menu. If we debug and then step over, which is F10, and you see it stepped over that line. But I will just stop the program, and that really demonstrates using the else statement. If we want to make a compound statement, for example, if x is equal to 2 and if if x is greater than 1, like this, well, both of those, if x is greater than 0, shall we say, then you can see that I'll put x, if x is greater than equals 1, if x is greater than 0. So you can see that now this is becoming like a compound if statement, so that if in the simple case we'll just say if that happens, then we'll just make one statement for the moment. If it does this and if it does that, then will it print out the, yeah, so if I just build that and try running it, and you can see that, well, it's at the breakpoint, and so I can just continue to run it, I think. So I'll just run that, and you see the yes situation, because both of those situations need to be satisfied. So but if one of them is not, you could try x is equal to 0 here, for example, then it would not, because both, so it's acting like an AND situation. We have what we also call an else if statement, which rather acts like an OR statement. Let me try this one out. Right, we've got x is equal to 2. If x is greater than 2, well, it ain't. X is not greater than 2, so you won't get that written out. But then you've got, is x greater than 1? You bet it is, so you should get this one here written out. Then you say, well, is x greater than 0? It is. X is greater than 0, but will this one get written out? No. This else if has got a little bit of a strange behavior, in that it only, once it finds one which satisfies it, it just won't continue any further. Let me see if that's true or not. So if I build that, and then I can run it, and so you get an output. The only output you get is x is greater than 1. It's a little surprising in a way that you don't get this output as well. Well, and that's the way that the else if behaves. It's like if, three of them. It's a little bit hard to get your head around sometimes, but that's the way it works. It's like right now. What we could do now is a sort of an exercise, following on from a previous exercise. Let me take a look at that. If I just paste the code in here, it's actually running at the moment, so I'll make sure I stop it from running, and then I can now paste that code in there, and I'll see what that should read T, not so okay, so you might recall what we're doing here. This was the code to actually swap things around, and at the moment it does a swap, because this is 3 and this is 2. Let me see how this works. If I build this, and then if I run it, I'll get that disappeared pretty smartly. Where is it? There it is. 3, 2, and then it swaps it around. I don't like the way that's a bit mixed up there. I'm going to try and put a line in between those two, and the way I'm going to do it is stop my program, and I could put it in here. Where am I? Control Z to get rid of that. I'll put a to run that. Now we've got okay, that's around the wrong way. Let me just fix that up with a \n, sorry. That should be a \n saying to start a new line. That's what we call an escape character. Okay, so we can run that, and it just simply puts in an extra line and swaps the two around. Now that should be from what we did from the previous exercise. But what I'd like to do now is this. If this is bigger, if the 3 is bigger than the 2, then swap them around. But if it's 2, 3 already, then just leave them. It's part of the sort procedure. It's just the first step to sorting numbers. But let me just try and do that. Now, at this stage, you might pause the video and try doing that yourself. The idea is that if this is bigger than this, which it is at the moment, then swap them around. But if this is 2 and this is 3, then don't swap them around. So if you'd like to pause the video and see if you can do that yourself, having looked at the lesson so far. Okay, well, if you're back now from having a go yourself, did you get something like this? You need to say if now I, the first one, is bigger than the second one, then you need to do all this stuff. If you're going to do all this stuff, then you need some curly braces here. If I just drag that down, okay, and tab it in. Now that means that you'll do all of that stuff here. So I might put a little reminder to myself. So if the first is bigger than the second, then do that stuff. Well, okay, well, let's just see if it works for a start. So I'm going to build the program, and then I'm going to run it. And so you see, it is bigger than that one, so indeed it does do a swap, so that I is bigger than J, so it swaps them around. But let me test it, and if I start off with a number here which is smaller than this number, then it shouldn't do any well. You're not going to know, are you? But we can single step and confirm it. But if I build that and then run it, you should find the variables are just left as they are. The 2 and the 3 is left as they are. Well, we really need to confirm that by putting a breakpoint in here. And if I run it down to the breakpoint, then I is greater than J. Now, is I greater than J in this case? No, it's not. That's a false statement. So watch what happens when we just continue the program, or I'll do an F11 once again to single step, and bingo, you see it bypasses all of that code and then starts to, be careful, don't do a F11 here, you'll get into trouble. But it's printed out the 2 and the 3, so it's about to print out. If I just continue to run that, as a matter of fact, that should give you the numbers have stayed in place. Okay, so that's an example of an exercise of using the if statement. A few points on this. If we've got using one to the I, we use what we used to call a pipe sign, where that means that this means or. So if I equals 1 or I equals 2, then print out yes. The and situation is the double ampersand. If this is true and this is true, which indeed it is in this situation, then both of them are covered. Then it prints out yes to the screen. This thing, you might be asking, why don't we use a single ampersand? Well, a single ampersand is reserved for other things, among them being it's what we call a bitwise comparator, which is bitwise comparison, which is really goes back a long way before the other and. Okay, so it's a double. Just remember, it's a double ampersand. If we look at a switch statement, a switch statement is more or less like a multiple if statement. Let's take a look at that. I'm going to introduce that code in here, take the breakpoint off, and paste my code in here. And it's a switch statement. Now you might think this is pretty glamorous. Switch. Let's just see what it does for a start. I'm going to build it, and then let's see if it works. I'm going to run it, and then it's going to give me 5. Now why did it give me 5? Well, it starts off with x has got the value of 5. What I'll do, I think I'll just close this and I'll single step it. So I'm going to start off here, and let's try and run the program, and then I want to single step it. So F11 will switch. Now it switches on the value of x. You see x has got the value of 5. So where do you think it's going to go? It's going to test this one. It's going to test this one and say, 5, that's what I want, and so it should print out there, you see, and then it will break and not consider anything else. So let me see, if I single step F11, then it jumps down to here, and once again be careful not to press the F11 again. I'll do the F10, which is here, and it steps over and then goes to the break. Now what it does then, it jumps out of the program. You see, if you didn't have these breaks, you'd find it sort of drops through, and it'll do the next one. In this situation right now, if you didn't have that break there, it would go on and do this one as well. So make sure you do include those breaks. Now you could look for the help if you want to double click on this and press F1 and go and get some more help on the switch. As I say, it's not really, I prefer the if statement, and the reason is you can't in here say if x is 4 if x is 4 and y equals 2, you can't. It's not as versatile as an if statement, but so it's really pretty well a glorified menu system, I think. Now we therefore now come to the most important statement, I think, of programming, and that's the for loop. So let's take a look at that. I'll just copy this code in. Now, so what we've got here, I'll just stop this, take the breakpoint off, and then copy my code, paste my code into here. We've got now int I less than, we've got too many of those. Okay, now what it's doing is, well, let me just see what it does. I'm going to build it and then just run it. And it's going to print out the numbers from 0, 1, 2, 3. Okay, well this is a for loop, and it means for I equals 0, starting at 0 and going all the way up to 3 because it's less than 4. And this means increment I by 1 every time you go. Now, therefore, notice that you've got these semicolons in between. It's not always easy to remember this stuff, so you need to go back and look in the manual now and again to remind yourself. I mean, why isn't that a comma? I don't know. It's a semicolon, and you just got to remember it. Also, the other thing you have to remember is that it's never got like an equal sign. You can make a terrible mistake here by putting just an equal. You know, that looks pretty good, but it's not right. You must have a greater than or a less than. You could have greater than or equal to, that's fine, but it must be greater and not just equal. That's the way they've designed it. This means greater than or equal to 4. So in this case, let's see what happens here. If we run the program, it's going to give you the 4 as well, you see, as the run the program, give it a 4. Where's it gone? Try that again. Right, run our program. Flash before our very eyes. I is greater than or equal to 4. Yes, and that's because there's a very silly error there. I is, yeah, that's I is less than or equal to 4. It should be. Let's see if that works. We'll just run that straight away. So it gives you I is less than, so 0, 1, 2, 3, 4. It includes the 4 as well, you see, in this situation. It looks like 2 lines. In fact, it's only 1. If I were to bring that up like that, then that would be absolutely identical to what we've just been doing. It's all now. You notice where the semicolon is. You see the semicolon is here. But it's very tempting to put the semicolon here, but don't. Right, now what if you now want to write just a few other things. You could have I minus minus here, and then you'd go for a big number down to a less than or equal to a smaller number, or greater than or equal to a smaller number. You could have I plus equals 2, for example. When it goes up by 2 and that sort of thing. So it's got quite a bit of flexibility there. I'll just undo all that. Right, now, as I was saying, what about, I think that this, then what if we want to make more than one statement, you see, as you go down? Well, what I'll do, I'll just put in another line here, and it'd be interesting to see what happens in this case, and I'll tell you what will happen. It will do exactly what it did before, and then finally it would print out this statement here. And the reason is, this needs to be in a block. And so both of these lines need to be executed in the for loop. You need a pair of braces here. Now, so I'll bring that one bit down here somehow or other. I'll cut it out and put it here. And then I can just, now let's see what happens. If I build this, build a solution, then when I run it, it's going to do both of those things, you see, within the loop. So this is your first loop, second loop, and so on. So this is the way you make it. It's really called a block of code, and it's a way of doing two statements in one, really. And this is the block, so you must include those braces if you're going to do more than one statement. What you might like to try to do at this stage is this exercise here. It looks fairly trivial, but you want to print out 1, 2, 3, 4. Well, that's going to be quite straightforward. Let's give you a clue here. You can just print out that in. That will include your space in between. In this case here, you want to print out 1, 2, 3, 4, 1, 2, and so on. You're going to need a loop inside a loop. So you'll need two loops, one inside and one outside. You could try printing these numbers out, and you'd be using I minus minus, in other words, to make the counter go down from 4 down to 1. And this one here is interesting as well, because you want to print another loop inside a loop, but so you're going to print these numbers out onto the screen. Well, but what you're going to need is, you're going to need two loops, but the inside loop is going to depend on the outside loop in some way. That's for you to work out. Okay, let's take a look at some other basic constructions, and that's the while loop here. Then let's just try that out. While I is less than 4, do this. Int I equals 0. We can't really have int. Well, I is less than while. I've declared it more than once. That's not very clever. Okay, so let's see what this bit of code will do. I'm going to build it, and then I'm going to run it. And you'll find that it does pretty much the same as what we just did. It's like a for loop, in fact. And so you're going to ask, well, what's the difference? Because it's sort of a bit of a nuisance. You have to do it. You have to do this by hand, so to speak. You have to increment I as you go down. So it tests this out. You see, is I less than 4? Well, it is less than 4. It's 0 to start off with. So it will continue down, increment. It will come back up here. You see, it will loop around and come back here, and now I is equal to 1, and is 1? Yes, it is. It'll continue around until it hits 4. We could single step that if you like. We could, and just show that I increases by 1 each time. So that's the while loop, and there are just variations on that, which is the do while here, which has got the do here, and the while down here, which is a slight variation to having the while and just the while on its own like that. Well, there's the old goto. We don't see that very often. That really goes back to prehistory. Using a goto, what we do is we put in a label here. You can call this anything you like, and then you put a colon here, and that makes a label, what we call a label of your own making. And then you say in your code, if something or other, goto, that's the one we're talking about. Now that really is prehistory, the old goto, still with us. And then you can therefore go to my label, so it will go down here. You see, it will bypass. So it's if you look here, what it's doing, it's saying here it's going from 0, 1, 2, 3, but if I is 2, make a detour, go past this line here and do this. You see here, you only get the outputs 0, 1, 3. The 2 is missing, and that's because you've got the goto there, and it just jumps over that particular line. The conditional operator is a strange one. It's like a bit like an if statement, but what happens is this: you've got I equal to 1, right? So then you test it here. You say, is I less than 2? You bet it is. I is less than 2. So what happens in that case is that it will do the one which is the first one here, which is that corresponds to it being true. If I is less than 1, which indeed it is, it puts the 3 in here. That if you change that and make that like 5 or something or other, then this one here will be executed. So it's a bit like a multiple if statement. You can just play around with that. Okay, well, that will do us for this session. There's some exercises there to do, and that should be the most of lesson 2.